Good morning, everyone. My name is Kevin Knopf, National Product Manager with Graybar, and I would like to welcome you to Graybar's G2Talk presentation on the 6 key considerations for optimizing your control panel. This talk is a part of a webinar series we offer each month for our industrial customers. We have a great discussion lined up for you today, but before we get started, I'd like to cover just a few housekeeping items. First of all, if you were one of the first 50 people who joined in on this presentation, you will receive a coupon for a free cup of coffee, courtesy of Graybar, as a thank you for your time today. Also, at the bottom of your screen, you'll see a box for questions and answers, Q&A. Feel free to submit questions throughout the presentation. We'll address as many questions as time permits at the end of the presentation. Lastly, our G2 Talks are all archived on the graybar.com website, so you'll be able to view this presentation again or recommend it to others. We're happy to team up today with Panduit. As an electrical distributor, Graybar works alongside Panduit to provide industrial-grade products for machine builders and panel builders to help you get your products to market faster. You can visit graybar.com/industrial to learn more about all of our solutions. At this time, I'm happy to introduce today's speaker, John French. John has been with Panduit for almost 10 years, specializing in OEM and IC MRO applications. He has helped develop and educate customers on Panduit electrical and industrial automation product line solutions. Prior to Panduit, John ran a harness house specializing in military and communication harnesses and also worked as a sales engineer with AMP Tyco electrical products. Over this time, John developed expertise in most aspects of electrical power and grounding connectors, crimp theory, and termination tooling. In fact, John is known in the industry as the go-to guy for best practices and standards for bonding, grounding, and crimping. So without further delay, I'd like to turn the presentation over to John. Take it away, John.
Thank you, Kevin. Really appreciate the opportunity to speak to everyone today. There's a lot of information I'll be covering. Any of it at all that you have interest in or want greater details or even some samples, just get with Kevin or your local Graybar rep, and we'll be glad to get those items out to you. So today we're going to be talking about the control panel and some of the 6 major top-of-mind issues. We're going to be talking about space optimization, network cabling, terminations, noise mitigation, safety, and security. And we'll go into each one of these topics, again, just high level, and we can get more information out to you. We got white papers and product bulletins, all that we can make available at a later date. So what I want to look at first off, let's look at some trends that are happening in the production area. First off, let's look at global population. And there are some reports out of the trends up to 2020 that the population is going to exceed over 8 billion. But what's really key here is that over 70 million are going to be going into this middle class. And with that, that's going to generate a tremendous amount of consumer spend. So what does that mean to manufacturers? It means that there's going to be an increased demand on industrial production. There's going to be demand for about 30% more water, 150% more energy, 100% more vehicles. So we're looking at a tremendous amount of spend there that we end users and manufacturers are going to have to ramp up to satisfy. So that's going to create some great demands onto them as to how they're going to approach this and be able to satisfy these demands. One of the ways of doing that is they're going to have to get more connected. All of us have our smartphones. Everybody's really wants instantaneous information anymore. So looking at some of the things that the Internet of Things is going to impact, over 100% of the plant floor devices will be providing data by 2018. By 2020, up to 30 billion devices will be connected. So you can see how the network is going to play an important role as far as our manufacturing capabilities and meeting these demands that are coming up. And what we found is that not all manufacturers are ready to fully understand how to capitalize on this opportunity. So again, there's a big scramble here to get this network connectivity out to this plant floor. So by doing that, there are several ways. First off, we're going to look at the network side of the items that need to go inside these control panels or go into devices. One of the things that's happened in the past is as they connect a Cat 5 or Cat 6 cable, they just tend to sort of terminate a plug onto the end of it and plug the cable in. Well, that practice is not beneficial as far as performance and reliability. So one of the things that we recommend is the use of a patch panel. Have a place to land these cables as they come in, whether they be copper or fiber. Either way, we need to land those to a patch panel so that we now can have a place that we can provide testing and checking and just to see if our connections are good. Now, right now, we don't need the bandwidth that Cat5, Cat6 can give us, but eventually we're going to. So we need to have the capability there so you don't have to redo this later on. So there is the need, again, for a patch panel, and we have these available as DIN rail versions. Also, the need for fiber and copper patch cords, and there's a big difference when it comes to patch cords. You can buy some offshore, very inexpensive, but you're not going to get the performance. And again, you may not need it today, but tomorrow you may need it. We do have certified to completely tested patch cords that can be utilized, because as this network gets inside these control panels on our machine, these things are going to be moving around. The patch cords give that capability to be able to make that connection. Also, the use of fiber is getting more and more prevalent out in the plant floor. So we have many solutions that will address that, making it easier to terminate. There used to be a lot of people were afraid of fiber because of the terminations. With now a very easy termination, and we can assist with that. Also, fiber gives us the ability to be immune to any noise issues, and that's one of the key concerns we're going to cover in a little bit, the noise that can occur. And again, fiber is going to give you that capability of eliminating that possibility. Also, plants are getting larger and larger, and if you get any more than 300 feet, you need to, again, start considering fiber as a solution as far as carrying that data. So again, we can get into greater detail as to the options and everything available for this type of product. So let's get into the control panel itself. Again, as we get more and more data inside these panels, we don't want to have to open these panels up to be able to gain access to this type of equipment. So we do have ports available that allows you to gain access to the network inside without opening that control panel. Because we have some great issues here with safety, with lockout tagout, with arc flash that we have to be aware of. So if we can eliminate the need for opening that panel, we do have devices that will allow you to do that. Also, security is a key factor. We have some very small clips, clamps, blocks and locks that will help as far as blocking off unused ports for any of the managed switches or any other network device that's being utilized on machine or inside the control panels. Very often I'll walk a plant tour into somebody's plant, and I'll see that some of the workers may have their cell phone being charged on a port that's inside one of these devices. So you don't realize the security risks that are involved if you allow that to happen. So by blocking off unused ports, you can eliminate that security risk. Also by locking in key cables that are crucial to the operation to keep somebody from accidentally unplugging. Again, these are very useful tools, very inexpensive tools that can provide that low layer of security. So now let's look at the control panel itself. And what we want to do is try to help optimize the use of space inside these control panels. And there are several ways we can do that. One of them is with some of our Panel Max line. What these products do, and these are different than anybody else out there that has any type of duct and that. And again, this is where Panduit began back in the 50s, is by creating this duct. We have three key components here that will help maximize the space inside, also help with noise issues. So we have our corner duct, which can be used in the corner of the panel, uses unused space there. We have our DIN rail wiring duct. We're going to get into explanations on these products in a little bit, but that will utilize the space and actually can give you up to a 30% panel space savings. Then we also have our shielded duct, our shielded noise shield, and the duct itself. And this is going to greatly reduce the segregation, the separation that you have to keep your network cabling away from any of the noisy devices inside these control panels. So we'll get into more detail onto each one of these products. But by utilizing something like this, even on existing panels, it can free up some space inside these control panels. So we're going to begin with the noise issues that occur. And anybody that builds control panels or any type of machinery can relate that anytime they introduce the network, they do have issues with noise affecting that. So looking at noise, we have our sources, which can be servo drives, VFD drives, contact switching, lighting, things like that can produce these noise sources. And then we have our victim wires, which is our communication wiring, our high-speed counting signals, controllers. All these different types of devices are very susceptible to any type of power that can be around them. So what's this equate to? It could be productivity loss, downtime, troubleshooting, and a lot of times just really not knowing what's occurring and how to correct it. So again, noise is a very real problem, and we can help you address those issues. One of the ways of looking at this, again, there's a 3-layer approach, and we'll be getting back to these layers during the presentation. But there's shielding, there's segregation, and there's proper bonding and grounding. And I've got hour-long presentations on each one of these topics, where we're going to brush through it very shortly here. So we're going to start talking with shielding and filtering. So when we start talking about the noise-producing items and then our sensitive network cabling, we normally have to at least maintain a 6-inch airspace separation to minimize any type of noise that can be generated. So you see here in the example, it shows the noise-producing items and how sensitive the cables fire, and how we have to really keep some type of air gap between these to be able to keep that noise from coupling. You also see in the chart here, there's 3 types of noise. There's an inductive, there's a capacitive, and then there's a coupled noise. So again, it shows you the paths, how this is affected, and with this diagram, we can actually see how we can best provide a shielding solution on these types of opportunities. So one of the ways we can do that is by putting some type of barrier in between, as you notice where the arrow's at. So by putting a metal barrier here, we can block that noise from being introduced. By also doing that, we can bring those 2 items closer together. So again, we can eliminate some of the space that we're using inside these panels and gain that space back to be able to utilize it for other types of equipment. So we have 2 products that address that. We have actually a noise barrier that you see down on the right-hand corner. Then next to it, we have actually a shielded duct. This is our standard duct that has a tin foil wrapped around it. And what this is great for is around drives and that, where you have to normally used to have to keep 3 to 4 inches of separation. You can go right up next to the drive now with your network cabling and not be affected by the noise that's being produced. So either one of these products can be deployed anywhere in the panel and can greatly reduce the segregation. Sometimes it's not possible, or also reduce the noise that can be generated. And again, reduce a very important problem that a lot of control panel builders are facing. This here is a demonstration we have. We actually have a tool that we have our noise shield and our shielded duct on. We have a drive, and we have a source wire and a victim wire. And the 2 scopes there actually shows you what can happen. If we were to run our victim wire close to that noise-producing source, we can get on the left screen there up to 4 volts peak to peak of noise introduced. So again, the way to reduce that was to separate by about 6 inches. And if you did that, you would get the screen on the right, which is about a 0.5 volt. But by utilizing the products that we have there, we can actually accomplish that same degree of protection and still keep our cabling very close, and again, gain that valuable space, that valuable real estate back inside that control panel. So we have a video of this later on. If anybody wants it, we can make this available that shows the actual application. So that was the shielding and filtering level. We're going to go now into wire segregation. Again, another way of addressing noise issues inside that control panel. So when we look at that, we need to sort of identify what are our noise-producing items, what are our maybe light-duty items, and then is our network, where are our cabling that is very sensitive. And what we can do here very simply is to use different colored duct to be able to house the cabling from those different devices. So that way anybody looking at this control panel later on can quickly identify where they need to route their cabling and where duct should be, they should avoid if they need to run any type of network cabling, or if they're running any type of power cabling, let's say they're hooking up another drive, they have a quick route that they need to follow. Again, some places use just all one color, but if they can utilize the multiple colors that are available, it can really minimize any future problems that can occur inside that control panel. So we'll show you here again an instance. You see on the left side, you see that the typical control panel and how we have our drives and that, and we have everything separated. And then we're using a different colored duct to be able to show that these are areas where it may be safe or unsafe to be able to run any type of network cabling, or maybe an area that we may need to put some shielding products to protect the network inside here. So this is a real live example, again, of a control panel that is utilizing the black duct for down around drives and the noise producing items. It's using the gray duct for areas that may have a slight amount of risk, and then the white duct for our pure network cabling, so that we can, again, keep it separated and keep it segregated. You notice down there is a white and a black duct very close together. That means at that point we would need some type of shielding in between. You also see the blue cover duct that satisfies UL 508 specs as far as intrinsically safe. So again, that's a code, again, just to show you that the particular areas are intrinsically safe by utilizing the blue duct. So again, by taking this color coding, we can actually help in the segregation and help with any future changes that may occur inside this control panel. So we've covered our shielding, we've covered our segregation. Now we'll get into grounding and bonding. And this type of topic, again, I've got great presentations on, because this is a growing problem, whether it's inside the control panel, whether it's inside a facility or on a machine. Proper bonding and grounding will eliminate a lot of key issues. And this is noted by the NEC codes and also by UL 508. Anything that is non-current carrying metal has to be bonded correctly. And again, I see this every day, that these rules are not followed. And again, this can create some very serious problems later on, even to safety of employees and that. So again, what this means is that everything in that control panel must be tied back to the equipment grounding conductor. So let's look at that conductor. And what we can do here is everything, and one of the things that we do recommend, and a lot of control panel builders offer, is a galvanized back panel. Reason being is that there's been a tendency again in the past for using a painted panel, which may look good, but you have to grind the paint off. By using a galvanized panel, everything we bolt on there has the same potential to ground, and that's what we're trying to accomplish. That's the purpose for this ground bar, is that we can provide as large a ground plane as possible, connect all the equipment that we can to this so they have the same path to ground, and there's no difference in potentials. If there is a difference in potentials, voltages will move. Again, I got another great presentation just strictly clarifying those points. So we do have a ground bar. It is a UL listed ground bar. Very few of them out there are. So if you want more details on this, we can get those to you. We have in multiple lengths, can be isolated or not, and it has the hex head design on the lugs, so you don't have this single slot screw that likes to strip out. So again, we can get you more information on this, because it does satisfy UL 508 specs as well, and again, a UL listed ground bar. As I mentioned before, the back panels being galvanized, and they should be bonded together. We do have the flat straps. There's reasoning behind the flat straps, and we can go into that on another presentation. But we do have those available. Again, we want to extend that ground plane, keep the potential to ground the same, and that's what we're trying to accomplish with this approach. This is a larger picture. Again, there's a lot more than just the ground bar. This practice needs to be utilized throughout the entire panel or on the entire machine. So even to the motor drives, all these different components that tie into this control panel, we need to make sure we have the proper bonding and grounding for all cases here so that we have, again, equal potential to ground for all the equipment. So now let's look at space optimization inside these control panels. It's pretty much like a puzzle. We're trying to put as much as we possibly can into the smallest box that we can, especially if you utilize any type of stainless steel enclosures. It can be very challenging to try to get everything in there, and usually when they get a design done, all of a sudden there's something else that needs to be added, and it sometimes can create issues as far as trying to find that space, and sometimes it may lead to compromising where we're installing these items, and that could again jeopardize with noise some of the critical networking components in there. So we're going to look at this. We're going to see this picture several times. This is a typical picture of a control panel showing a couple drives, some DIN rail, and some of the terminal blocks that are on there, and some of the components that we normally put inside a control panel. But now we have the task of either adding something new. So we've had this panel. It's a tried solution, proven solution, but we want to add an Ethernet switch, or we want to add an additional drive, or we need additional DIN rail space. How are we going to get that out of this same size control panel? So one way is to make a larger panel, which can be expensive, or we can utilize some of the products that we can address here. One of the things is that we can utilize our Panel Max DIN rail wiring duct. Now what this does is this actually has taken two pieces of duct that were separated by a DIN rail, brought them together, and mounted the DIN rail up on top. We find that most control panels have plenty of depth to them, so this makes it very easy to do. A lot of places are even using an elevated DIN rail. Why? Because they want to have the ease of access to that DIN rail, to the terminal blocks on it. Also, it makes it easier to wire and troubleshoot. So by, again, utilizing this Panel Max DIN rail wiring duct, which comes in 2, 3, and 4 inch heights, we can actually free up about a 30% panel space savings. And I'm going to show that in a little bit later on in a diagram. But again, we can gain space inside the control panel just by using this type of product. We can also, again, with this example here, it shows the DIN rail, the typical duct that was on either side, how we can bring those together, and you can see the panel space savings that we can gain here. So let's say if you have a redesign you need to do, you need to add a switch, you need to add a drive, this simple product will actually help you in that and actually makes it quicker and easier to install. We also have what we call our corner duct. And what this utilizes is space in the corner. Even if they're not using a side panel, this can be utilized because we have brackets that will support it. But this takes space in that corner that's not normally used. And again, we'll show you some of why this will help reduce maybe about a 10 to 20% panel space savings. With this diagram, you see what was typically done. On either panel, we would have a piece of duct on the edge, but we'd have to keep it in to be able to allow for the removal of the cover. So by utilizing this corner duct, we're able to bring and gain benefit from having that space and using it. This is also a great tool for entry cables. As they come into the panel, this is a great place to run those cables up until they take their horizontal run. So we can gain a lot of extra space here just by utilizing this and be able to access the cover very quick and easily. So now we have our panels that we looked at before. So we have our before and after. And I'm going to show you some of the components we've decided to add to this very same size enclosure and how we was able to accomplish that. So what we want to do here is add, you see here we're adding an additional drive in the green. We're adding some additional DIN rail space for, our, again, some more terminal blocks or whatever components we need to put. And also we're adding an Ethernet switch. So again, these three items we need to add to the existing panel. We're able to do that here because we've been able to utilize some of the solutions that we've shown. One of the solutions is adding the DIN rail wiring duct. Again, we're able to bring those two pieces of duct together, elevate that DIN rail, and gain some space. So you can see in the yellow here where we've actually added those two components. We've also been able to add our noise shield and our shielded duct products, again, to allow us to get closer to those drives and not have to worry about noise being introduced into our network. By utilizing those two products, we've been able to gain that space needed for an additional drive, the Ethernet switch, and the additional DIN rail space. This again shows you some of the up to 40% panel space savings can be utilized here. So again, instead of having to make that control panel larger, we can still use the same size and still gain room to be able to add additional components. Because that could save hundreds of dollars when we look at a typical control panel build. We have a lot of reference documents available. Again, if you go to our website and type in space optimization, noise mitigation, wire duct products, grounding products, that'll get you to a lot of the information we have available on those different types of products. We also have white papers available. We are partnered with Hoffman as far as on the control panel side of things. So we have a great white paper with them. We also have some great white papers on bonding and grounding and all the different types of topics, segregation, all the different topics we've been covering. We have white papers and that available for you to be able to, again, give you that information required to be able to build these correctly. Also, when you look at Panduit, again, the word Panduit was developed 60 years ago by taking panel and conduit and combining together. So again, Panduit invented the duct. We're a leader in this respect. We're coming out with all the time all types of new products that addresses key issues inside these control panels. So again, get with your local Graybar rep and that, and we'll be able to help you get you information and product information on these different types of solutions. We have also developed, what we call our PCDs. These are Panduit configuration drawings. And what this has done, this has taken just this control panel and broken down all the different aspects of these panels and all the different solution sets that we have that addresses key issues inside of here. So this is, again, a great tool. We have it electronically. We could share with everyone that gives you all the different areas of concern here and the different product groups that will address those concerns. So again, get with us and we can make this available for you. We also have, again, support materials as far as product bulletins, installation instructions, customer drawings, AutoCAD, and samples of all the different products, solutions that we have addressed here today. So again, we really appreciate the opportunity to be able to address these and promote these to you. And as always, too, we also have a lot of other products that addresses all the different concerns as far as machine building, control panel building, wire harness manufacturers. So everything from terminals to power connectors to grounding solutions, from direct barrel grounding all the way inside to the devices themselves. So again, a lot of new products that we have available, and feel free to get with us. We'll be glad to get that information to you. And again, we really appreciate the opportunity of your time. And at this point, we'd like to open it up for some questions.
Thanks, John. Really appreciate it. This is Kevin Knopf with Graybar again. At this time, we would like to address some of those questions that you have. and that have been submitted. So if you have not done so, please submit your questions online so we can review them. And you can do so by using the Q&A box at the bottom of your screen. If we don't happen to get to your question, a Graybar representative will follow up with you after the presentation. So at this time, the first question we have, we'd like to address are basically the first one is how can I guarantee the performance and security of my control panel network, John?
Well, it's very simple. One of the things we have to do is to maybe get away from how we used to do things. Again, how they would take a Cat 5 or Cat 6 cable and just terminate a plug onto it. That is actually the worst performing termination you can do in the field. First of all, the cable coming into that control panel is a solid cable. Any of your patch cords in that need to be stranded so that you have the flexibility. You start flexing that copper solid cable and you'll start getting issues. So we recommend terminating to one of our Minicom jacks. That jack, again, we do have the punch down type that a lot of people are used to, but the Minicom one we have now is quicker and easier to terminate. It's because it uses an IDC format. We do not have to untwist the pairs. If you untwist the pairs, you change the performance of that cable. By utilizing this jack, you can actually not untwist the pairs, and we can guarantee Cat 6 performance just by utilizing that jack, and then by using that jack to create a patch panel so that any future changes in that occur inside a control panel are easily accessed just by changing a patch cord. As I mentioned earlier, there's a big difference on patch cords. So again, you need to use one that is certified, that has been tested, and guaranteed performance in that. By taking those 3 steps, you can guarantee that you're going to have the performance there later on when you require it. And as far as security, being able to provide the locks and blocks to block off unused ports and lock in key cables that can't be unplugged, we can guarantee that performance.
Thanks, John. Next question we had was from Andrew. Do customers seem to like the separation with colors?
It's been a mixed review. We have some that just insist on like all white or all one color, but a lot of customers are realizing that this is beneficial for the end user to be able to identify what areas if they need to make any type of changes. If they're not making any changes inside the control panel, then the single color is fine. But there's always changes occurring. So again, it is very real. A lot of customers are starting to adapt to it.
One of his follow-up questions was if the noise reducing comes in black.
The shielded?
Yes.
Well, it has that reflective surface on the outside, and you can put our standard covers on it. So you could put a black cover onto our shielded duct.
Okay. Thanks, John. Next question comes from Tim. Where should cable shielding be connected? At equipment terminal of the terminal block?
What was it?
Where should cable shielding be connected? Is it at the equipment terminal or possibly or the terminal block? If I'm reading this correctly.
Well, he's probably referring to shielded cable. Do you terminate both ends or not? I'll tell you what should be done and then what is usually done. For the most part, a lot of people only terminate one end, and that's because they don't want to create an additional ground loop or antenna. However, if you follow proper bonding and grounding practices and everything has the same potential to ground, you can ground both ends. So you really should be grounding both ends. But if you are not following the practice of grounding and bonding everything, then you will have some noise issues. So again, it all depends. You should be grounding both ends, but for the most part, a lot of people only bond one end.
Next question, what are the 3 layers of noise mitigation?
Well, the 3 layers is shielding, segregation, and then proper grounding and bonding. And again, if we do the grounding and bonding correctly, we will not need to do as much of the segregation and shielding. That's just in cases where we can't separate them and we need that extra protection.
Thanks, John. Well, everybody, I really appreciate it. Based on the questions that have come in, I hope that the presentation really hit on all the points that we had laid out for you. We're about out of time at this point. If we didn't happen to get to your question, a Graybar representative will follow up with you after that presentation. As a reminder, the presentation will be archived on the graybar.com website. Again, we really want to thank you for your time today, and we hope you will join us again next month for Graybar's G2 Talk. Thank you very much.